Hi, my name is Jessica Poole, and today I'll be discussing my KaggleX project. A bit of my own background. I have a PhD in political science from the University of Cincinnati. My subfield is public opinion and survey research, so I took many courses in probability and statistics, used primarily SPSS, and utilized quantitative methods in my research. I transitioned into the private sector after earning my degree and currently work at a construction software firm in finance and accounting. My goal is to move into a data science role with a modernized skill set. My industry interests include finance, technology, government, and market research. Through the KaggleX program, I learned SQL and about machine learning and how to use BigQuery, GCP, and other Google-based data science and machine learning related products. I gained proficiency in Python and refreshed my existing statistical research knowledge, built upon it, and learned a lot of new things I didn't know before. For my project, the focus was on the availability of affordable housing in the United States, particularly the affordability of available housing stock. I honed in on two housing categories: homes on the market or recently sold, called inventory and sales, and homes for rent or lease, called rentals. My project covered a number of data science topics, which I will explain in more detail shortly. The research question is, what factors affect the percentage of available homes households making median income can afford? The target variable was generated using housing data from Zillow and median household income from Federal Reserve economic data. I used an equation that factored in median household income and other relevant factors to classify available homes as affordable or unaffordable. That binary became a percentage score I later used in regression models. The predictor variables came from other data sets, which included the Consumer Price Indicator, Dow Jones Industrial Average, Gross Domestic Product, also several healthcare indicators and student aid indicators. I engaged in data cleaning, mainly in BigQuery using SQL, and narrowed the time frame for inventory and sales to a 10-year time frame, 2011 to 2020, so all predictors could be used. The rentals data was narrowed further from 2014 to 2020 because Zillow didn't start tracking rentals until 2014. After cleaning my data sets, I built and tested models in Python using several methods, slightly altering my input data for appropriateness. I used several regression and machine learning methods as well as logistic regression. After these tests, the model that worked best utilized the adaptive boosting algorithm, or AdaBoost, with a random forest regressor. AdaBoost is a machine learning technique that falls under ensemble learning, which is a type of method that creates multiple models and then combines them for improved results. AdaBoost can capture nonlinear relationships by building up weak learners in a model to become stronger learners. And while this was created as a binary classification method, it can be modified for regression, which is what I did here. For the model run on rentals by state, my mean squared error, or MSE, was 70.964 with an R squared of 0.769, which was improved from other models which had a much higher MSE and lower R squared. For inventory and sales, the MSE was 1.19 with an R squared of 0.83, which was also an improvement over other models. Other findings for the AdaBoost model. If you look at the feature importances graph on the right, unsurprisingly, state had the greatest effect on both models, but other factors had a small effect, more so for inventory and sales than for rentals. There are a few caveats regarding the findings. The data was skewed as about 3/4 of the homes were in the affordable category. The model does not take into account certain factors like household debt or credit score. While housing data was state-level data and median household income was available both nationally and by state, the indicators were all national level, so some dimensions may not have been captured. I created national level data sets and tested these out as well, but there were too few cases for predictability. Overall, I truly enjoyed working on this project and I got a lot out of the experience. I learned about various regression, classification, and machine learning methods. This was a mix of learning by repetition and researching new information to add to my data science toolkit. And if one method doesn't work, try something new. Thank you for your time.